Liftoff. Welcome back to Anoma Research Day. This is Anoma Research Day. If you are not here for Anoma Research Day, you are in the wrong place. Check your URL bar. We are now in our third track of today. The third track, namely Systems Design Selections, will start with a presentation by Jeremy on the system of Anoma. As a friendly reminder, you can always leave questions, comments, requests, etc. in the chats online, on the X stream, and the X and YouTube streams, and we will take a look at them and forward those to the presenters. Jeremy, take it away.
Hi, thank you. It's going to be hard to follow up from the wonderful talk that Jamie gave, but I will try my best to do decently. So I want to talk to you guys about the system of Anoma and kind of what it is. But first, I kind of want to get at what does Anoma actually set out to do? I've heard Anoma sets out to be a coordination mechanism for enacting other people's intents. Further, Anoma wishes to have mechanisms to ensure trust between multiple parties, and we don't want to be horribly slow and every participant to care about every other state while doing this. I would argue that the first point kind of leads us to being really a general execution platform, because people's intents, that to me sounds like we're trying to compute some type of computation, and it seems like we have some general idea of computation that we wish to seek out and solve problems with. Further, if you want to ensure trust between multiple parties, it seems like consensus is quite useful here, as this is how we come into an agreement upon certain facts of the matter. And thirdly, something that makes Anoma quite interesting is that we do not want to be horribly slow or every participant to care about every other state of the network. If you look at blockchains like something like Ethereum, everything is on one global computer where you have a bunch of data on there, which I would argue does not scale very well, nor gives you kind of the properties that you want to see. But how do you even get these properties of having this? Well, I would argue that in order to be useful and to do this properly, we have to be a distributed operating system. And the question then becomes, what is a distributed operating system? This is always the nebulous term that we all struggle with. But all that I mean by this is that it's an operating system in that it provides an environment to operate inside. For example, you most likely have a Windows machine or a Unix machine, but if you're operating inside of a Unix machine or even a Mac, something interesting is that I would argue it is a C machine. You have a compiler for compiling C code, you have documentation via the man pages, and it provides a decent enough environment for computing C functions in which we grow things on top, like higher level languages, GUIs, stuff like that. And lastly, that it's just distributed in some way. I don't really have a formal notion of how it's distributed or which parts, but the operating system just must be distributed in some capacity. And in order to explain it, I kind of want to break this down into a few layers. The way that I kind of want to stack kind of viewing the abstraction process is that at the base layer, there exists some hardware. This could be an existing operating system like Unix. I don't particularly care. Lastly, layered on top of that is some kind of runtime. And the runtime has a lot of interesting things, like I'll get into what engines are, objects, and something called a Anoma level. Very bizarre. And then lastly, at the top of this stack, after we have our runtime defined to start evaluating things, we can talk about more high-level things like controllers, which are, I will get to that in a bit, resources, whatever resources are, and local domains. I want to kind of go over each of these layers in kind of greater detail and give meaning to each of these, because currently to me these just look like a bunch of words. The base hardware layer. As I mentioned, this is just the base operating system that we're running things on. We could theoretically run this on an x86 64 chip, just having Anoma being the operating system on top of a normal x86 64 CPU. We can even have custom hardware and have really cool stuff like hardware GC, which would be really fancy and wonderful. But in reality, I think for the time being, we must settle on running this on the operating system of Erlang, also known as the Beam, which sits on top of Windows, Mac, and Unix. And yes, I count Erlang as an operating system because it has system monitors, it has interrupt routines. It is, in all essence, an operating system, and we operate inside of it all the time. It is beautiful, truly beautiful. Before we get to talking about the Anoma runtime, I kind of want to give some motivation as to why the runtime has some of the features that it has. And by doing this, I want to describe the higher level operating system, which is kind of the domains that we're working inside. And the first thing I want to talk about is controllers. I believe often controllers are called blockchains. So I think we can view Ethereum as a controller. And the participants who validate the state are called validators. And it's great, right? You get a bunch of people together, they agree upon certain facts of law based on some programmatic rule set. And a certain amount of participants can be Byzantine, but that's fine. Consensus is great for doing this. However, Anoma is interesting. It's not just one controller. The Anoma network is just not one blockchain. Rather, there's a bunch of controllers. For example, we may have a controller that talks about hotels, and you may have just a single chain for dealing with hotel transactions and another one for dealing with trains. And these can even come together in weird ways known as like chimera chains. And there's even useful stuff even for your own computing. And in fact, I would argue that controllers ought to be programmable and that users ought to have an easy time to program their own controller and rules thereof. I want to motivate this with some proper examples. For example, this is what I want to do on my own computing. I have a bunch of computers. I have my phone, I have a laptop, I have a desktop, and I have a server somewhere in the US. And this is great. I can do computation on my phone. However, my phone is slow. I don't want to calculate prime factorials on my phone. I'd rather ship it off to my computer and then get the answer than just have it on my phone, right? It's horrible that I would have to use a slow device. And so, well, what if you could change consensus such that instead of doing a normal proof of stake or proof of work sort of deal, you have proof of resources, i.e. each of your computers basically says, hey, I have this much computing power and this much storage. And based on this, it gets the weight on, let's say, accepting a job that people submit. And based on this, it will choose the most optimal computer in which to do this operation. So in a way, I would like to be able to change however this controller works to be able to do computation like this. There is other trade-offs too. For example, I believe the default consensus mechanism that we wish to have for Anoma is a very, very fast one. One so fast that we do not want to waste time answering queries which are complicated. Usually this is a service called indexing, and parties could have outdated information or different information or subsets of state. But this requirement, you don't need it for everything. For example, if you have your own computation that only you are sending transactions to, well, this could be as slow as you're sending transactions to. I don't need this to be at lightning speeds. And in fact, it'd be really convenient if I could program and have hooks into different times into this. And so I could slow down the machine, but have different reliability of queries over the system. Some other examples of this is that I think it'd be fairly common to have controllers, not just of yourself, but of you and your friends, right? Like I imagine you would have controllers over games that you and your friends are playing, such that you can imagine if you're playing a D&D sort of game, that there's rules that you must abide by, right? Some D&D sets, while some role-playing sets are much more number crunchy than others. What if you don't like the rules in the particular variant that you're playing? It'd be nice if users could push code and have authorization to change the rules while the game is live, because maybe some participants don't like some rule or another. And I think it should be the job of us to design such a model that we can control and change this without people having to hard fork the code base and kind of roll their own thing, because that simply is not practical for non-technical communication and people actually getting real work done. I also want to kind of talk about a local domain. So I was talking before about ways in which participants can agree upon state in a controller, but the problem is that this can't be everything, in the sense that I need something to coordinate these controllers. I need something to say, hey, I want to have a new controller, or I want to be a validator on this controller, or I want to do some complicated things like that. Worse off, you may want to subscribe to various controller states, right? Like, for example, there may be the controller for the D&D game. You may want to subscribe to, oh, hey, is it my turn to start doing things? What is the current state of the game? Can I do anything about it? And I believe this requires long-running processes in some kind of local computational environment. And you really do need something rich to deal with this. Leaving this up to shell scripts is simply not sufficient, right? Because you can imagine that if you do not design this as a proper operating environment, that, maybe it's fine. We have configuration languages like config files for deciding, okay, we have a controller over there and we connect it this way, and maybe we have a different language for saying, well, gee, I want to run some logic that everyone agrees upon, and maybe I have some Python code for kind of gluing this all together. Doing this in an ad hoc fashion leads to catastrophes and makes the general user experience not good for anybody. And then there's one component I have not talked about in this kind of operating environment, which are resources and transactions. I would say resources are kind of the core facts that we agree upon, right? We have this thing called the resource machine, and in the resource machine, there are certain invariants that must uphold, and it could even be run in more zero-knowledge environments to hide information to some capacity. And it would be great if we can agree upon rules and we get this via resources and transactions. And what's interesting is that we have a notion of intents. I mentioned at the start of the talk that there is a notion that users can submit intents. Well, what is an intent? Well, I would argue it is just some kind of inequality in this case, right? Let's say if you want to trade 5 tezzies for 4 bananas, well, that is an open inequality, right? I'm willing to give up 5 tezzies, and I'm just need to look for 4 bananas. And what I find really interesting is that we have seen this kind of in the literature before, in Prolog and quite in particular, in that it can solve for random variables that I throw at it. And I would argue that all solving is doing a unification-like process and maybe doing constraint satisfaction. The exact details don't matter, but I believe that if we could have a declarative representation of computing, I think it would help the problem of solving and dealing with intents quite a bit. And all hail Prolog, we are now making the 6th generation, we're now making our own 6th generation project of Anoma. So I am looking forward to the grand future. Finally, with that all of the way, I can finally start talking about the runtime that kind of holds up this operating system together. The first bit of this runtime is engines. Engines are actors, which means that they can accept messages. They only know about themselves, really, and they can respond to messages by sending more messages to other places. Engines are completely isolated. If one engine over here dies, well, then this engine over here is still fine. They should be completely isolated. It works just like actors in Erlang. The exact details are quite a bit different. But what is interesting is that I mentioned before that in the local domains, we need to subscribe to things. We need to start worrying about, things are coming from this controller over here, and I need to react to it. And this looks a lot like an engine. Like, we use engines as a meta construct for designing Anoma, but I would argue that it is vital that it is also part of the system. After all, we could leverage engines to do the following. For example, imagine you submitted an intent for the 5 tezzies for the 4 bananas. How do I know if this is solved? How do I figure out what happens there? Well, if I have myself an engine that is existing on my local domain, I can have it subscribe to the controller for specific things, right? So before I send out the intent, I could have a system event that triggers this to say, hey, please watch out for any transaction that has this resource in it. And from there, I can get information on if my intent failed during the transaction process or get general diagnostic information otherwise. Further, I can even leverage this to send messages to solvers, even written in C++. You can imagine that if I have an engine and I have some way of talking to outside of Anoma, to the outside operating system, either through FFIs or using ports or what have you, I can leverage a live actor to send messages to something else doing work and bring that information into Anoma using processes. So I would argue that engines are very much so a concept in system and something that we should consider for the grand operation of the Anoma operating system. And I think engines are great because actors are really wonderful about dealing with concurrency. I think Joe Armstrong had the right idea. Next, I want to talk about objects. Objects are really simple. Something that amazes me is that if you look at non-object-oriented languages, you have so many concepts. You have modules, you have functions, you have compilers, you have type systems. I would argue all these are objects, and you can derive pretty much everything out of objects. So you can have a very minimal VM and a minimal amount of work to actually realize concepts. So I think objects are just a great abstraction mechanism. For those curious about objects, I would recommend go reading a paper by William Cook about data abstractions revisited. Now, this sounds kind of familiar. They can only receive messages, and objects only know about themselves. This sounds a lot like engines. I would argue to you that objects and engines really aren't too different. I was having a conversation the other day that potentially an engine is just an object with extra features on top. And so I think it is a great basis for dealing with engines. But yes, Jamie, you have to pass him the mic.
Thank you. What extra features or feature, if I have an object and I want to see if it's actually an engine, what should I look for?
The way that I would conceptualize it is if it has a mailbox of some kind. What is interesting is that you can attach a mailbox to an object by composing it in another object. Since objects only know themselves, you can take a mailbox object and the object without the mailbox and have these together work as an engine and have a lifetime.
An engine, I can recognize every engine is an object.
Yes.
Not every object is an engine,
Correct.
and I can tell if something is an engine by checking if it has a mailbox.
Yeah, pretty much. There's a few lifetime constraints in what would actually happen in practice, but yes, basically.
And very briefly, a stupid question: what is a mailbox, please?
A mailbox is just it could be a queue. It's any data structure really that takes in messages that people send for you to process later.
Right.
So rather than getting to the message right away, the object has some computing and it may be stuck processing, and so it can't get to this message quite yet, and so it has to go through the queue in order to be able to respond back to messages.
A queue provided by the OS does not count as a mailbox. It has to be a mailbox connected to the object.
Yes.
Thank you.
Yes, no problem. Something else that is great about objects is that we have over 40 years of research on how to make objects reflective and bend them to whatever we want. And in particular, I would say the meta-object protocol is a great example of being able to take objects and bend them in ways to make them useful in extraordinary circumstances. So you can change how allocation works, you can change how finalization works. It's beautiful. Lastly, I think objects can provide a very clean layer on top of resources. I think something that we've found is that programming in raw resources in the resource machine is quite difficult. There's a lot of invariants that you have to satisfy, and it's not really clear how to do it. It's kind of like writing in assembly, right? You have a bunch of registers. You have to worry about what goes in the register when you're doing basic algorithms. This is all not necessary. And I would argue that if we have a mapping from objects to resources, we can greatly simplify this process, especially since objects are simple in the sense that they can basically model anything. They can model modules, they can model libraries, they can model compilers even, which means that if we can turn the simple abstraction into resources via some mapping, we can effectively turn this local computational model of objects and talking about engines into something that the resource machine can kind of process. And I think this is a great gain for actually making the system quite simple. So I would argue that object orientation is quite great and it fits our use case quite well. Next up, I want to talk about really a language that kind of ties this together. And I dub this language the Anoma level. I would say Anoma level is a declarative/functional object-oriented language. Note that some people will say functional and object-oriented are different because of weird notions, but no. Object orientation and functional are completely compatible and are best friends. You can go ask Guy Steele if they need tail recursion. Lastly, it could be declarative. What do I mean by this? As I mentioned before, when I was talking about resources, it seems a lot like Prolog. And so when I say it's declarative, I believe we can realize a programming model in which we can give it partial arguments and have the missing arguments filled in by unification or constraint satisfaction problem or by having a search, in a way making solving user programmable and giving easy ways for people to write their own solvers and hopefully reason about solving, as it's a core part of the system. Great. So Anoma level will be the language is the interface to the system. I suspect at the end of the day, like many years in the future, that we will have less than 10,000 lines of Elixir and millions of lines of Anoma level to bootstrap all this in. Currently, we have more than 10,000 lines of Elixir, but every day when we develop Anoma, more and more of this Elixir code can be brought in system and we can cut it from the code base. So I am looking forward to having a fully specified, spec'd out system such that we really can have like 5,000 lines of Elixir and have the whole of Anoma. I think what's really interesting about Anoma is that GUIs can be built, right? So for example, we're not all technical users. I would like to program at my system, but I am not everyone. Many people just want to sit down at their computer and have it be useful, right? Like I want to listen to music, or I want to transfer files between my various devices, or I want to browse certain pages that people have made. And I believe that Anoma should aid people in doing these kinds of tasks. And I think that it is, and I think Anoma can aid this both in single user applications along with multi-party applications due to these trust assumptions and sharding. And I believe that the system has a lot of interesting properties. Like for example, we can store all code online. So I can just have libraries out in the ether, and then I can grab that in my system and inspect it. I don't have to go through a weird compilation cycle. I don't have to necessarily get artifacts. I don't even have to go through a build cycle. The code is just already there live. We don't have to go through a build run. All that can go away. Yeah, like everything should be hot code uploadable. Any engine you spawn to subscribe to subscriptions and get messages, this should be able to be upgraded. We should be able to change this because, well, maybe my code was wrong. And we're not all perfect people. We all write bad code. And I would argue that having reflective designs and tools that allows you to reflect in the system can make a system understandable. For example, when my Unix machine segfaults, I have no idea how to fix it. If my web browser freezes, I have no recourse. A normal user wouldn't know how to do anything, but if you know the system and you have the tools, you'd be able to inspect in that, fix that component, or give it to someone who can, right? I could give you the state of the application in its bug state, hand it to an expert, they could maybe fix it, and that would be a wonderful bug report that is actually actionable. Lastly, the language that we design here must be general and ergonomic enough to support all our domains. We must support distributed programming as well as Erlang does, right? We should not be giving a distributed programming language that is worse than Erlang. We need engines and supervisors and all that, and we ought to have declarative programming as this makes it easier to write intents. In conclusion, having complex coordination problems inspires having a proper system to work inside. It is not sufficient to just have shell scripts to make the system come together. That'd be a tragedy. I split Anoma analysis on 3 levels. One is the hardware, then on top of the hardware is some runtime, and then on top of that is the domain where I would say the operating system actually takes place, which is the counterplay between the local domain and the various controllers. Lastly, having a unified language gives us clarity of thought. It makes everything debuggable. And I want to encourage new paradigms of computation by making these systems ergonomic and advanced computer science. I want this to be a system that I want to use myself, most importantly. Yes. That's it.
All right, thank you, Jeremy. Questions from the live audience?
One question from the internet. Do you take any inspiration from Lisp?
Yes, yes. This is a distributed list machine. It is really a distributed list machine. So, yes.
Michael, or Rob, or whoever.
I have 2 questions. First, we find a bug and want to fix it. How do we roll out the fix in your system?
Sure, there could be quite a lot of different ways. So it depends. So we have a notion of controller. So if, for example, it is isolated to your local domain, easy. I just recompile the code, hot updates, everything, great. Now this gets tricky, right? If you are the sole validator of a controller, or you control it completely, right? In that case, you can just push out the code by fiat and say, well, I agree to these changes because I control this, therefore it's law. Otherwise, you may have to vote on upgrades. So for example, something I found interesting was that in Tezos, people can provide updates to the blockchain, and people can vote if they like the changes or not. You can have the system as well. I think this very much so depends on the particular controller because users can override the controller mechanism and enact different policies that they want, and even have special privileged users or security patches that they may fast track, which can be security vulnerabilities in their own right, depending on how trust assumptions are done.
Okay, and the second question would be, what's your stance towards client diversity? If everything is written in Elixir or Erlang and there's a bug in Erlang or Elixir, how do we deal with it?
Yeah, that's a good question. My hope is to have at most 10,000 lines of Elixir. I want to like cut this and then eventually maybe have just like a C compiler or something really, really, really fast. The point is that there should be many. The thing that will be, I guess what I encourage is different compilers for the Anoma operating system. And I believe that you can bootstrap this in probably less than 10,000 lines of C, meaning that I think people just make their own. It shouldn't be that difficult, ideally.
Yes.
Yes. JJ asks, how would the resource machine be realized in the Anoma system or runtime?
Sure, in the Anoma runtime. So the way that I would kind of think about it is I'm kind of thinking about it on, let me go up a bit. I'm thinking it around like the domains currently. So to me, I'm still not fully sure, but what I do know is that at the Anoma runtime level, we have a bunch of objects, and there exists a mapping between objects and resources to be able to run in a resource machine. Locally, you don't really need to run the full resource machine because really you're just doing computation in private. You don't need to agree upon it with everyone else, right? It must abide by the rules. You know, if you have constraints on how big a number is, well, that should still be obliged. And if you were to try to submit it online and forge it, well, that's going to fail, obviously. So I think you'd have a resource machine in sort of the Anoma runtime as well to run things against. I think it would be realized in system, and even stuff in the domains, I would argue, is still a part of the runtime. I just kind of split it into these levels as it gives you a kind of different level view of the system, when in reality all the domains are all Anoma level code, and it defines the rest, so the lines get a bit fuzzy because it's a reflective system in a lot of ways.
Rob.
Yeah, my question is related to Michael's second question about client diversity. Where does Beam sit in terms of determinism across different architectures, microarchitectures? Because you mentioned before, like x86 64 is like being like an intended, but I know, for instance, for like WASM, like non-determinism is an issue, like for like Arch 64 against x86 64.
That is a good question, and I do not know. I've not looked into the specifics of Beam on non-determinism on there. I know that if you run the code on various operating systems, you get the same result, but I just don't know about the non-determinism part.
Okay.
Yeah.
The good news, at least compared to something like perhaps threading in WebAssembly, is that the concurrency assumptions or ordering assumptions are very explicit in the actor model. So as long as Beam on different platforms is correctly implementing those, the only thing we would really need to check for is like, are the floating point types not floating point, are the base types implemented correctly and consistently and deterministically, which seems less likely to be a problem. Other live audience questions? Jan, and then Jimmy.
So, can you write Anoma apps in Anoma level?
Yes.
Is this the expected language?
Yes.
So what's the relation with Juvix?
Well, currently I don't have a Anoma level compiler, and I don't have a Anoma level compiler to, let's say, Cairo or RISC-0 or anything like that. But I guess it depends. Like, for example, you could imagine, just like Unix, there's a lot of languages which compile on top of Unix. For example, I have the Lisp programming language, I have the Erlang programming language, all these kind of compile down to the base platform. So it becomes a question of, is there a compiler down to the level of Anoma level? And like, for example, even without Anoma level, there's a lot of ways that Anoma can be leveraged. For example, I think we have some plans with Juvix to compile out its modules and upload them online. So the system is fairly capable of having these. So I would say Juvix would be something like a different front-end language in that kind of sense.
At least in part, I understand the idea of Anoma level as a potential replacement in the future to Anoma from the perspective of Juvix.
So, as I understand, you want to kind of create object-oriented abstraction over a resource machine, more or less.
Yeah.
And that kind of implies in my mind that you might have a lot of resources being created and consumed just because you do it unified way. And since we have kind of limitation on the amount of resources in transactions /block /whatever, could it be like super inefficient in the result?
Potentially. I think these are optimization questions that you could align with batch compilation. For example, if you know the inputs and outputs into something, so let's say you have a big chain of computation, but the input to the entry point is 2 arguments, and the output entry is maybe 3 arguments. You could maybe align some of the operations in the middle and optimize it so it's not creating so many objects in an actual transaction that you send to a controller. To me, this is an optimization question that should be investigated more fully in terms of, well, can we provide traces of some of these of these computations, or what can we really do there? So I would say it depends, and I think it's the optimization question.
Thanks.
Jamie.
Thank you for the lovely talk. I read the paper by Cook on something revisited.
Data abstractions revisited.
Data abstraction. And the message I took from that was that every time I hear you say object-oriented, I should hear extensional.
I think so.
Because you don't look inside. The only thing you know about an object is its method.
Yes,
so
yes.
it's fundamentally an extensional philosophy. And there's this lovely line in your conclusions where you write, having complex coordination problems inspires having a proper system to work inside.
Yes.
So I'm wondering how much of this is your ideas about the perfect programming language or environment, with a concrete application being a test case for, and how much of this is the application itself. And to be clear, that's not a criticism. I just want to understand where the boundaries are in the structure.
Yeah, I would say it's hard to say, right? So for example, if we're making video games, something that a lot of video game studios have to decide is, do we make a game engine, or do we just take Unity that is off the shelf? Right. When you make a game engine, you're making an operating system, I would argue, because you're having an environment in which you compute inside. You have to have code reloading of some kind within there, so developers, when they develop, can get updates to their games and not having to recompile the entire engine. You end up designing all these layers so someone can design a game. In the case for Anoma, it's quite interesting. I did not have all these ideas coming into Anoma. A lot of the ideas that I ended up having are are all inspired from the great research that you wonderful folks have done. Like I wouldn't have thought of, maybe if I do declarative object models, and the object model is very weird because I have to think about how it compiles to resources. This is not coming from it from the perspective of this is an ideal. This is kind of ingesting sort of the research that we have and trying to come to a conclusion on how can you make a system usable and friendly, because if our goal is to solve coordination problems and to have systems that people actually use, I think it requires a proper operating system design if we want to get out of just it being crypto, and crypto is just useful for money, right? I want to have like things that I can play music on and have my computer share data. Currently at the moment, I just have rsync, and if I delete a file, it ends very badly. The alternative is to use something like Dropbox or Microsoft Windows and give them all my data. And I would argue that Anoma can give the power to the people in order to have sovereignty over your own state, over your own data, and share sovereignty with other people for coalitions that you may or may not care about. Does that answer your question?
Yes, it does. If I understand, what you've said is complex coordination problems characterize what the OS should do.
Yes.
Thank you.
Yes, Patrick.
Just 2 comments. One from the internet. Somebody said, deep technical architecture breakdowns create stronger builders. Love seeing this level of system design analysis shared openly. So thank you for that. And the other thing I'd say to anybody listening or anybody in the room that hasn't, Jeremy and I did a podcast recently, and Jeremy breaks down his philosophy on system design and architecture, and I would recommend it. It's podcast is called Deeply Intense. It's episode number 4. You can find it published on our stream.
Yes, it's titled Worse is Better. Yes.